power calculations in the AC circuit, it is important for us to understand some of the terminologies really associated with the AC power. Now first one is instantaneous power. Now instantaneous power means if you measure the power at that particular time, then we call it as a instantaneous power. Now in our previous video we have discussed about the instantaneous voltage and then the instantaneous current. Now let's say if instantaneous voltage V of t is given by Vm sine omega t, and then if instantaneous current I of t is given by Im sine of omega t plus or minus, okay, with some phase shift, then we can calculate the instantaneous power with P of t is equal to the power is given by the product of voltage and then product of the current. Now let's substitute this instantaneous voltage and the current in let's say equation A here. If you substitute here, we'll have Vm of sine omega t, okay, sine of omega t times Im of sine omega t minus some phase shift. Now about that phase shift, if this phi is negative, then we can say that the voltage is leading the current, or when phi is positive, then we can say that the voltage is lagging the current. And then if phi is equal to 0, then voltage and current are in phase. Now this happens when the load is only the purely resistive. Okay, now if we simplify this one, if you multiply and simplify this one, then you will get the final value half of Vm Im cos phi minus 1 by 2 Vm Im cos of 2 omega t minus phi. Now let's assume this one, okay, let's name this one as equation B. Now we have got the instantaneous voltage equation, instantaneous power equation with this one. And then let's say if the value of the omega t is known, then phi is also known, Vm and Im is also known, then if we calculate, we will get P of t will be equal to 1 by 2 Vm Im cos of phi minus 0. Reason is here, if we try to find the average power for this part, you will get 0. The reason is there we have double frequency, which means here we have like this kind of 2 cycle of frequency. If you find the average, this part and this part will give you 0. Now that's why our instantaneous power value is given by only this part, only first part. And then the second terminology that we have is the average power. Now in order to calculate the average power, we have to understand the relationship between the root mean square and then the instantaneous voltage and the current. Now the root mean square VRMS is given by Vm by root 2, or we can also write Vm times 0.707, and then for the current we can write that IRMS is equal to Im times 0.707. And then if you look at the instantaneous power here, we have P of t is given by 1 by 2. So 1 by 2 we can write Vm divided by root 2 times Im divided by root 2, then we have cos of phi. Here we have 1 by 2 will be equal to 1 by root 2 times 1 by root 2. Now this here we are doing some manipulations, because with this we can make into this form. Here we can substitute like this. So our P average, okay, now let's write P average is given by VRMS times IRMS cos phi. Now this is the average power that you have you derive it from the instantaneous power. Now, okay, let's say for the different types of load. Now if load, okay, for different types of loads, let's see first for A, purely, okay, I don't know, okay, so if it's purely resistive, your phi will be equal to 0, which means or your voltage and current are in phase. So you will have your power P will be equal to VI. And then if it is purely capacitive, then you will have your P will be equal to VI cos of plus 90 degree. And then for the inductor, for the purely inductive, it will be negative 90 degree. Now this is these are the formula that we are going to use for the AC power calculation.